Hi, everybody, and good morning. Welcome to your second of third personal finance lessons. And this one's going to focus on compound interest. So, just like your simple interest, there's a formula for simple interest, there's a formula for compound interest. As I mentioned, this unit is very formula based, which is good. You only have to know how to use the formulas, and there's not much else to it once you've practiced that. So compound interest, a few quick points here. So the fancy way to talk about compound interest is that it is calculated on the accumulated value of the investment, which includes the principal and the accumulated interest of prior periods. It's calculated at regular compounding periods and then added to the principal for the next compounding period. What you need to take away from that, or what that's a fancy way of saying, is your interest earns you more interest. This is good if it's an investment. This is bad if it's a loan, which is why credit cards are bad. So let's kind of backtrack. Let's go back to the last lesson, simple interest. Simple interest, you just get paid interest on your original value of your investment or of your loan. So you get interest once a year, let's say, and you pay that interest, or you get paid that interest for an investment every year, the exact same amount, and that original value of your investment or loan is the only thing that accrues interest or earns interest. However, for compound interest, your money earns you more money and more money and more money. It snowballs. Or conversely, if it's a loan, like a credit card, which is why credit cards are bad or can be bad, if you don't pay off your loan on time, then your original borrowed amount earns interest. And then if you don't pay that off, that interest, you get charged more interest on top of that. So there's these regular compounding periods, which we're going to talk about in a little bit. And then that gets added to your original amount of money, and then that earns you interest. And then you take that little bit, add it to the total value, earns a little bit more interest. So you always want to, for an investment, you always want something that's compound interest. And for a loan, if you can avoid it, you don't want compound interest, or you want to make sure that you make your monthly payments or whatever the payment period happens to be. And whenever you can pay something off early, you always should. Now, what I just said, I'm kind of going to give it to you in a graph here just to further demonstrate this. So we have similar conditions. We'll say the interest rate's the same, but one's compounded annually and one's not. One's just simple. So you both start at $2,000, same interest rate. Now, if you take a look at that gray line is the simple interest. That is linear. It's a straight line. It grows at the same amount of money every single year. That rate of change is the same. So simple, linear, you know what you're getting. If you look at the other one, though, the red one, that's compound. And in the first, several years here, there's not a ton of difference. However, the gap between these two starts to grow. And it's not easily evident from this picture, but if I was to continue that, say to go to 20 or 30 years, this eventually starts to skyrocket. It's exponential, which was the focus of our last unit, right? And our simple one just kind of plods along at the same rate all the way across. And that gap between the two gets bigger and bigger and bigger because, again, the simplified statement I gave you, your interest earns you more interest. And earns in the sense of an investment, or you're going to be charged more interest if it's a loan. So what to take away from this? Simple, linear, you get paid the same amount every single year. Compound, exponential, it's going to increase or decrease, but we're going to talk about it in the sense of exponential growth. It's going to change. It's going to keep getting bigger and bigger and bigger and bigger. It's eventually going to skyrocket. You're going to see that exponential increase. Again, I can't stress this enough. Your money, if it's an investment, is going to earn you more money. If it's a loan, unfortunately, that money you didn't pay, that interest you were charged, is going to earn you it's going to make you be charged more interest in the next period. And it just snowballs from there. Compounding periods. So these are things you're going to have to know. These are the terms that are going to come up over and over again for these questions. And some of you probably already know what these mean, but just in case. Annually. Annually happens once a year. So if you were paid something compounded annually, it's once, or has the numerical value of 1. Semi-annually, every half year, that would be twice a year, which would have a numerical value of 2. Quarterly, I'm going to stop writing the words, they're kind of self-explanatory. Quarterly, you're paid every quarter. How many quarters are there in a year? 4. Monthly, that would be 12 times a year. Weekly, there are 52 weeks in a year, so that'd be 52. If you have a job, you're probably familiar with the term bi-weekly, which means you're paid every other week. How many every other weeks are there? Well, half of 52, which is 26. Daily, there are 365 days a year. Make sure you know these or you're able to refer to them. There's going to be a couple others that might pop up every now and again, but for the most part, that's going to be like 99% of the compounding periods that we're going to look at for this course. Now we're at our formula. Our formula is very, very similar to our exponential one, which is why I set it up that way. So it's not like you have to memorize so many different formulas with so many different letters. So we're going to start the same way. A equals P, the number 1, R divided by C. I'll redo that R just in case. R divided by C to the exponent CT. Now, if you walked away with any understanding of exponentials, looking at that formula, it looks complicated, but really nothing is different except for we have this introduction of a C letter. And we know it's exponential too because, yes, I showed you in the graph it's going to be exponential, but you have an exponent. And in that exponent, there are letters, there are variables. So that's how we know this is exponential. And we know it's growth because it's got 1 plus, not 1 minus. Now I know we went over all of these letters in the exponential unit, but I want to review them. So A, if you have forgotten, is the final amount. Or in financial terms, it is the future value. P, remember, was our starting amount or initial amount. Financial terms, it's your principal value. The number 1, just the number 1. R was your growth rate, which for finance is your interest rate. T was time. So the only new letter here is C. And C stands for the compounding period, which are all of those terms that we just looked at. So make sure you have that formula copied down, and we're just going to do a bunch of practice with it for the rest of this lesson. First example, Brendan wants to invest $700 for 5 years. The investment pays 4% per year. compounded annually, what is it worth? So remember I focused on the simple interest lesson. There's some look-fors. So the first look-for you're going to read is either the word simple or compound. Those are the only two types of interest we're going to look at. This does not say simple, this says compound. So right away, your mind has to go to the formula you just saw and forget about the simple interest triangle. The next thing you want to look for, once you've identified that it's compound interest, what is the compounding period? Which is almost always going to be the word that follows compound. Annually. And then what number did we think annually was? Once a year, it's 1. What is it worth? It's asking you, what's the final value? What's the future value? Just like for simple interest, it's a good idea to get in the habit of writing all these numbers down, or all these letters down that you're going to use. So we want to know what it's worth. What's the final amount? P is principal. It tells you in the question. He invests $700 to start. The interest rate tells you right here. And don't forget, R is not 4. It has to be as a decimal. So if you have forgotten, don't forget to divide by 100 to get 0.04. C is the compounding period, which is that word that follows compound, annually. How many times does it compound per year? Once, because it says annually, once per year. T is time, and it tells you in the question, 5 years. Once you have all that written down, it's just plug and play into your formula. So just to get some practice memorizing this, I'm going to rewrite it. Now you sub everything in. P is 700, 1 plus R, 0.04 divided by 1, that's R divided by C, and then CT. Now 2 letters side by side just means multiply, so that just means 1 times 5. And 1 plus 0.04 divided by 1. 5 times 1 is 5. Enter that in your calculator just like you see it, brackets and all. So 700, open bracket, 1 plus 0.04 divided by 1, close bracket, exponent button, 5. Since it's money, remember, go to 2 decimal places. Even if I don't tell you, money is always 2 decimal places. You should get $851.66. Since it's a word problem, don't forget therefore statements. And you kind of know you did the question right, or at least you know you didn't do it wrong, because it says he's investing money, meaning it's growing. And we got a number that's bigger than 700. We got 851 and change. If you got a number less than 700, that means you did something wrong because it was an investment, it was accruing interest. Or if it was a loan, it's accruing interest, it still would have been higher. So just one quick self-check built in there. Since these are growing, they should always be more than what the initial value was. Our next example. Determine how much money you will have if $500 is invested for 6 years at 4% per year, compounded semi-annually. You might want to take out your highlighter. Might help. We're looking for simple or compound. We see compound. And then we know we're kind of using the compound interest formula. And then the word after compound is usually your C, your compounding period. How much money will you have? Okay, so that's your final amount. Your principal, how much you start with. You start with 500. Your interest rate, 4%, which don't forget, you have to make it a decimal, divide by 100. Your compounding period, so semi-annually, that stands for 2, twice per year. So this time it's 2. Time, how many years? 6. It's plug it all into our formula. Again, I'm going to rewrite the formula just so we get some comfort with it. 0.04 divided by 2, and then 2 times 6. Do the 2 times 6 part first. So 2 times 6 is 12. And then enter into your calculator just like that. 500, open bracket, 1 plus 0.04 divided by 2, close bracket, exponent 12. 2 decimal places, maybe pause it, make sure you get the same thing as I do. $634.12. And don't forget a therefore statement. And again, a quick built-in self-check. We know we probably didn't do it wrong. Maybe we had the wrong numbers, but we didn't do it wrong because we got a number bigger than 500, which makes sense. So hopefully after doing it twice, it's not too bad. Literally just plug and play into a formula. Example 3. Alex borrowed $5,000 to start a small business. The interest rate on the loan was 9% per year, compounded monthly. He's expecting to repay the loan in full after 4 years. Same idea, even though it says it's a loan, it's still accruing interest. It says compound, so we know we're using compound interest formula. Then it says monthly, that's your C value. So how much will he end up repaying? That's what we're looking for. The starting amount, he borrowed $5,000. Our interest rate, don't forget to make it a decimal. So divide that by 100, 0.09. Your compounding period is monthly. What number is monthly? How many months are there in a year? 12. Time, it says he's going to repay it in 4 years. I'm going to stop right in the formula. If you need to, you can. I'm going to go right to filling stuff in. Starting amount, 5,000. 1 plus 0.09 divided by 12. And then your exponent, C times T, 12 times 4. Do that exponent calculation first. 12 times 4 is 48. And then enter that into your calculator just like you see it. Go to 2 decimal places. You should get $7,157.03. How much of that amount will be interest? So we want to know now, so we're adding a part B here. That's how much he has to pay back in 4 years. How much of that is interest? Well, if he borrowed $5,000 and he had to repay that, how could you figure out how much of that was interest? Well, we could say I for interest is the amount that he paid back minus his loan. In other words, the future value, I'll put that a different color. The future value, the accumulated value, minus the principal. And a very quick calculation tells you that $2,157.03 was interest. Now, I didn't specifically ask it for this question, but an extension from this I could ask would be maybe something like, what would his monthly payment be? So if we know he has to pay that back in 4 years, how could you figure out his monthly payments? And this is a very oversimplified version, just introducing you to this, of what the actual calculations would be. Okay, so he's going to pay it back in 4 years. How many months are 4 years? 48. So if I wanted to calculate how much he paid per month, you would take that number and divide by 48, and you should get how much he would pay per month. So just keep that in your back pocket in case you see it. Again, that's an oversimplified version of how you calculate monthly payments for the sake of our class. Sometimes and oftentimes it's actually a little bit, well, not a little bit, it's a bit more complex than that because certain portions of your payments are going towards the principal and thus affecting the accrued interest, blah, blah, blah. For us, we're just going to simplify it, take that final amount, divide by 48. And our last example number 4. Jenna's investment has grown by an average of 12.6% per year, compounded annually over the past 7 years. How much would her $2,000 investment be worth? So again, you're looking for simple or compound. We see compound, then we see annually. That gives you your C value. We want to know how much it's worth at the end. That's our final amount. Our starting amount. She starts with 2,000. Interest rate. Don't forget to divide that by 100. So 0.126. Compounding period says annually. That's just 1. Time, 7 years. Again, I'm not going to bother writing the formula. If you need to, you can. Starting amount bracket 1 plus 1.26 divided by 1. And then 1 times 7. Make sure you do the exponent calculation first. 1 times 7 is just 7. And when you enter that into your calculator, 2 decimal places, $4,589.85. And don't forget the therefore statement. Now, if I asked you for this question, how much would her monthly payments be? Then you would have to take that number. How many months are there in 7 years? 84. And take that number and divide by 84. So hopefully that's okay. If there's any questions, let me know. And then your next lesson is on present value, which is the final lesson of the course, really, in terms of new material. We are going to do some review lessons. So you will have a couple more video lessons after that. And then while I have your attention, I just want to remind you of a couple of things. By the time you were supposed to have watched this, your finance assignments should be posted and available for you to see. So I want to stress to you a few things about those. First of all, make sure you do the assignment according to your last name. There's 3 assignments, 3 ranges of what your first letter of your last name is. Make sure you do the correct one. If you do not, then I'm not going to be able to assess it. Or I'll ask you to do it all over again for the correct last name. So make sure you don't waste your time. Secondly, for those of you that have been sending me pictures, this assignment has a research component on it, and I also want to see what you know, not what your friends know. So you do have to submit this assignment on D2L. There's no questions asked about that. You have to have your tech issues figured out by now. Now, the reason for that being is I want to make sure that there's no plagiarism. So there is a research component, which means you're going to have to do some research online, and you cannot just cut and paste off the internet. And hopefully most of you know that by now. So when you submit this on D2L, it's going to get run through a program like Turnitin, which if you're not familiar with Turnitin from your English classes, or history or law, it checks your submissions across the internet and across your own individual submissions, meaning like each other's, and it spits back a report to me on the originality, meaning is it plagiarized, is stuff cut and paste off the internet, did you cut and paste off of each other, etc., etc. Remember, I want you guys to work together, but everyone has a unique voice in how they say things and how they do things. And this is meant to be an individual project. So again, fair warning, do not cut and paste or write word for word off the internet. Don't cut and paste, don't copy off each other for your assignment. Okay? This is absolutely due. So your assignment is absolutely due on Friday, January 22nd at 3 p.m. There will be no late submissions accepted. Now, if you do by chance have some sort of crazy tech issue, you need to let me know as soon as possible. And then I'll talk to you on an individual basis on what we can do or how you can get your assignment to me the best way possible. But again, hopefully you have your tech issues worked out. And Friday is the last day of the course content. And then the following Monday and Tuesday are either in person or virtual, working on your CCA. Part 1 on Monday, part 2 on Tuesday. And I'll talk more about the CCA in future lessons. Well, actually, I could talk about it now. A little bit, actually. So before I get to that, though, one last thing about your assignments. You're going to notice for the finance unit, it's a little bit light in terms of the other units, in terms of amount of video lessons and workbook questions assigned. That's on purpose, to give you lots of time, 3 days, to work on memorizing or becoming proficient with this material, but also working on your personal finance assignment and making sure you do a good job on it. For your CCA, it is basically going to be an open book. We'll call it exam/assignment. Whether it's in person, whether it's online, it's going to be open book. How should you prepare for it? Well, you should make sure that you are organized with your notes. I would have them organized by unit. Make sure that you have done all of the reviews from your workbook. There's an exam review in your workbook as well. There's also 2 exam reviews posted in the content section of the course underneath exam stuff. You don't have to do both. You can only do one. And there's also some exam review lessons there. Now, they're not video lessons. They're just PDFs, but they have solutions. And you could try those questions, cover up the solutions, make sure you know how to do things. I would also make sure that you know how to do every starred question. So we did a lot of starred questions during the quadratics and trig units. Not so much in the video lessons because I've been giving you kind of oral reminders like, hey, this is an important question. But make sure you know how to do those starred questions. And make sure you're ready to go. So again, you are in control of your own success. You got to advocate for yourself. You do as much work as necessary to prepare you for your 30% CCA, which is basically going to be an open book assignment, split into 2 parts, covering all of the course material. And again, if you have any questions, email me, pop into the Teams meetings, whatever, message me in Asia, whatever you need to. I'm here to make sure you guys are all successful. So that's it. Your next lesson, video lesson anyway, isn't until tomorrow. If you want to work ahead, you could work ahead. But you got one more lesson, then a couple of video review lessons, and that's it for this unit. And last but not least of my rambling on here, remember I've put a checklist of things for marks in the activity feed. So you could click on that and check things off as you do them to help you stay organized, or at least just refer to those things so you have everything completed that you need to. But for this unit in particular, getting things in on Friday by that deadline is important for the course content and to make sure that I can have ample time to mark things, get marks back to you with feedback, and also have time to mark your CCAs. Talk soon. Have a good day.